Hello everyone, welcome back to my channel BE. Today in this video, we are going to learn about brute force approaches. Brute force means nothing but a straightforward approach to solve a problem. In that, the first one is a selection sort approach. Selection sort means start selection sort by scanning entire given list to find smallest element and exchange it with the first element, putting smallest element in the final position in the sorted list. Next, second step is scan the list starting with the second element to find the smallest among last n-1 element and exchange it with second element, putting second smallest element in final position. On the ith pass through the list, which we number from 0 to n-2, the algorithm search for smaller item among last n-I element and swap it with AI. After n-1 passes, list is sorted. Let's see this definition with an example. Okay, consider there are 5 number of element. Start scan by entire given list, find the smallest. Here the smallest is 2. Okay, putting smallest element in its final position and exchange the smallest position with the first position. In the second step, again scan the list starting with the second element, start from the 6 among last n-1 element till here we have to scan and exchange with the second element. From here to here the smallest element is 5 and exchange with the second position. And again in the third step, again start scan from here to here, again small element is 6 and exchange with the third position, and so on. In the ith scan we got the array in an ascending order. Okay, here a0, a1, ai-1 in the final position, the array we get in ascending order, and before sorting the last n-I element we have to swap the minimum element in its first position. Okay, this is all about selection sort. Let's see algorithm for selection sort. Algorithm of selection sort, array 0 to n-1, that means if we have 7 element, then the last position is n-1th element. Sort a given array by selection sort. Input is array a0 to n-1 of orderable element. Output is array a0 to n-1 of sorted in ascending order. For I 0 to n-2, do minimum is I. For j I plus 1 to n-1, do. If a of j less than a of minimum, then minimum is j. Then swap a of I and a of minimum. Let's see this algorithm by an example. Okay, we have 7 number of element. For I is 0 to 5, minimum is I. Set the minimum I, that is 0, minimum is 89. Next, enter inside loop, we set I 0. Next, increment j is I plus 1, 1 to n minus 5. Again inside the loop, minimum, if the condition check, if a of j less than a of minimum. Here a of j means a of 1, whether it is less than a of minimum, that is whether 45 is less than 89. Yes, then we have to set minimum as j, minimum is 45. Again increment j value to 2, a2 less than a of minimum, that is 68, less than minimum is 45, no, that is false. Again increment j, a is 3, whether a of 3 is less than 45, no, 90 is not less than 45. Again increment j, a of 4, whether it is less than a of minimum, a of 4 is 29, whether it is less than 45, yes, then minimum becomes set minimum as j, that is minimum of 4 is 29. Again increment j 5, that is 34, whether it is less than current minimum 29, false. Again increment j, a of 6, whether it is less than a of minimum, that is 70 is less than 29, yes, it is true, then minimum is 6. Swap minimum is 6, that is 17. We ended till here. Next we j is we moved to 1 to 6. Next we can't increment j, again out of the loop, that is swap a of I and a of minimum. Swap 17, a of I is 0, that is 89, swapped with a of minimum is 17. Okay, 17 and 89 is swapped. Next increment I 1 and j is start from I plus 1 2 to 6. Again the same condition is go from 2 3 4 5 6. We have to increment j value and check the condition. If the condition is true, then we set the minimum value, and after a of 6 we have to swap the minimum values. Like this same way, here the smallest element comes in first position, and again we start scanning from a second element. In this minimum is 29, then it is goes to second position. Like this way the selection sorts the given array. Next, analysis of selection sort. Input size is a number of element n. Then basic operation we did is key comparison, and the number of time it execute depend only the array size. Let take C of n denotes the number of comparison. Algorithm makes comparison for each repetition innermost loop j between I plus 1 to n minus 1, repeated for outer loop I between I 0 to n minus 2, that we seen in the algorithm, right? Next, C of n is a outer loop I 0 to n minus 2, j is I plus 1 to n minus 1, 1. Let's simplify it using summation. C of n is I 0 n minus 2, I plus 1 to n minus 1, 1. The first standard formula we know is upper bound minus lower bound plus 1. Apply here. Upper bound is n minus 1 minus lower bound I plus 1 plus 1. Minus 1 plus 1 cancels. Remaining is minus 1 here and minus I n. Next, separate the term n minus 1 and I. We know the formula for I is n into n plus 1 by 2. Here n is n minus 2. N minus 2 plus 1 by 2, that becomes n minus 2 n minus 1 by 2. Next, take out this n minus 1 outside, remaining is 1. Again put upper bound minus lower bound plus 1, that becomes again n minus 1 into n minus, here it is n minus 1 into n minus 1 is n minus 1 whole square minus this n minus 2 n minus 1 divide by 2. Next, take out the common term n minus 1. N minus 1 remaining is here n minus 1 n minus 2 by 2, that is nothing but n by 2 into n minus 1, which is belong to order of n square. Next, the selection sort is belongs to theta of n square on both the best case and worst case, and we swaps only theta n to n minus 1, that is less swaps, which is distinguished selection sort by other. Okay, in selection sort the number of swap is less, that is only n minus 1 swap we did. Second approach is a bubble sort. In the bubble sort, we use it to compare the adjacent element of list and exchange them if they are out of order. By doing this, ended up bubbling up largest element to last position on the list. The next pass bubbles up second largest element, and so on until after n minus 1 passes list is sorted. Pass 0 to I and less than or equal to n minus 2 of bubble sort can be represented as a of 0, a of ji, whether it is out of order or in order. We are checking whether they are in order, a of j plus 1 and a of n minus I minus 1. In the final position, what we got is a of n minus I to a of n minus 1. Let's see this definition by this example. Okay, we have an array 5 1 4 2 8. We compare the adjacent element, and if we exchange them if they are out of order. In 5 and 1, 1 is the smallest element and it require exchange. Okay, we exchange 1 and 5. Next, again in 5 is compared to next position, whether 4 is less than 5, yes, again swap. Next, from third position compare 5 and 2, whether 2 is less than 5, yes, again swap it. And again from fourth position compare whether 5 and 8, whether they are out of order, no, they are in order, and no swap. The array we got is 1 4 2 5 8, and what they said, by doing this ended up bubbling up the largest element to the last position on the list. The largest comes in the last position. Okay, next again go 1 4 2 5 8 we got, and again start checking 1 and 4 whether they out of order, no, and again start from second position whether they out of order, no, no swap. Okay, here 4 and 2 is smaller than 4, then it requires swap. Again start from third position and fourth position. 4 and 5 they are out in order, hence no swap. And again compare from 4 to 5. Again okay, we here this position we start 4 and 5 in order, no swap. 5 and 8 also in order, no swap. Finally we got the second pass. Okay, in this array, in this second pass we have one swap. We say the list is sorted when there is no swap, hence we swap again 1 2 4 5 8, and we uh, do the same steps. And in the last pass there is no swaps, hence the algorithm needs one whole pass without any swap to know it is sorted. We got in third pass, we see clearly in the third pass there is no swap, hence we can say the array is sorted. This is called as bubble sort. The analysis of bubble sort: input size is nothing but the array of number of element. Basic operation we performed is key comparison. Next, no best case worst case, because time is execute depend only the array size. Let us see of and denotes number of comparison. Let's see the algorithm of bubble sort. A0 to n minus 1 sort a given array by bubble sort. Input is an array 0 to n minus 1 of orderable element. Output is an array 0 to n minus 1 of sorted list in ascending order. And for I 0 to n minus 2 do, for j 0 to n minus 2 minus I do. If array of j plus 1 less than array of j, swap a of j and a of j plus 1. Okay, let's see this algorithm with an example. Here n is 7 and here it is the last position, and n minus 1 and it is n minus 2 position. For I 0 to n minus 2, that is 0 to 5. Consider in the first step I is 0, enter inside the loop, that is j 0 to n minus 2 minus I, that is j 0 to n is 7 minus 2 5 minus I is 0 5. Next again, if a of j plus 1 less than a of j, that is a of 0 plus 1, whether it is less than a of 0, that is a of 1, that is 45, whether it is less than 89, yes, true, then swap a of 0 and a of n. This and this get swapped here. Next again increment j by 1, that is a of j plus 1, 1 plus 1 is 2, whether it is less than a of 1. Compare 68 and 45, whether 60, okay, we swapped here. Compare 68 and 89, whether 89 is greater, yes, then again swap a of 1 and a of 2, that is 89 is swapped by 68. Again increment j by 1, that is a of 3 less than a of 2, that is whether 90 is greater than, whether here 89 is greater than 90, false. Again increment j, a of 4, whether it is less than a of 3, whether 29 is less than 90, true, then swap a of 3 and a of 4, that is 29 and 90 got swapped. Again increment j, that is a of 5 less than a of 4, that is 34 less than 90, true. Again swap 34 and 90, then a of 6 is less than a of 5, that is 17, whether it is less than 34. Okay, here 34 is less than 90, then swap the element. 90 goes here, 34 comes here, again swap the element. 17 is less than 90, yes. Next swap a of 6 and a of 5, that is 17 to 90, that is for I equal to 0. We got 45, 68, 89, 29, 34, 17, 19. Next we have to check for I is 1 and j is 0 to 4. Like this way we have to do for I equal to 1, 2, 3, 4 and 5. After that we can say the array is get sorted. Next, the mathematical analysis of bubble sort is: input size is n, basic operation is a key comparison, that is a of j plus 1 less than a of j. Next, number of time the algorithm, the key comparison is executed depend on the array size. Let's see of and denotes number of comparison. The outer loop from 0 to n minus 2 and the inner loop is 0 to n minus 2 minus I. Simplify the summation. I 0 to n minus 2, j 0 to n minus 2 minus I 1. 1 put upper bound minus lower bound plus 1 n minus 1 minus I. This is same as the selection sort in mathematical analysis, right? That is n into n minus 1 by 2 belongs to theta of n square. But the difference between the time complexity in selection sort and bubble sort is, we can see that in the worst case of decreasing array is depend upon theta of n square, but in best case it is order of theta of n. But in selection sort, for both worst and best case, the number of comparison is theta of n square, and bubble sort is less efficiency compared to selection sort. The third approach is a sequential search or a linear search. Here it compares the successive element of a given list with the given search key. We use a search key until either match is encountered or a list is exhausted without finding the match, that is unsuccessful search. This is also called linear search. Okay, for example, we have an element 70, 40, 30, 11, 57, 41, 25, 49, 52. The key value is 41. We have to check whether 41 is present in the list. If it present, then return it, or else return it is unsuccessful search. First compare 70 whether it is equal to 41, no, increment the I. Whether 40 is equal to 41, no, again increment I. Whether 30 is equal to 41, no, again increment I. Whether 11 equal to 41, no, again increment I. Whether check 57 is equal to 41, false, again increment I. Whether 41 is equal to 41, yes, hence we can say search is successful. Algorithm for sequential search: array 0 to n k. Implement sequential search with the search key. Input an array of n element and search key k. Output is the index of first element whose value is equal to k or minus 1 if no element is found. A of n is k, I is 0, while a of I not equal to k, do I is I plus 1. If I less than n, return I, else return minus 1. Okay. We can see here we take n, but if there is n equal to 5 and consider it is a 5 element in the array, okay, that is 4, 5, 26, 3 and 8. Okay, we have only this much. We have to apply sequential search for 0 to n. We know this is n minus 1. Then how n came? Okay, this is the question we get. Let k equal to 3. Okay, apply in n plus 1 position the key element here. Okay, that is 5th position. Okay, I plus 1th position. Here in the 5th position, set this as 3, key element as 3. Okay, this algorithm says that we have to set the key element in the nth position. If we have n equal to 5 element, then in the nth position we have to set the key element. Okay, next set a of n as k. A of n is 5, k is equal to 3. Got it? Next I equal to 0. While a of I not equal to k, while a of I, now a is 0, whether it is not equal to k, whether 4 is not equal to 3, no. Next increment I plus 1. Again check whether 5 is equal to 3, no. Again increment I, whether 26 is equal to 3, no. Again increment I, whether 3 is equal to 3, yes. Hence we got the element in array in the third position, element found at the third position. The best case is only one comparison. If the key element is present in the first position, then we can say it is a best case, and worst case is if the element is present in the last if element is not present in the list, then we say that is a worst case, that is a order of n, and average case is a probability of both success and unsuccess, that is order of n by 2.